We are lucky enough to be joined by an array of titans here, one of which who will be moderating us through the very first sessions. Ladies and gentlemen, please put your hands together for Albert Petschek, CEO of Bosch Digital Twin Industries.
I'm good. Hello, hello. All right, good afternoon again. Welcome, and my name is Albert. I'm here to talk about digital twins and physics-infused AI for oil and gas and energy utility companies, a really powerful technology. And let's be honest, I think digital twins is a buzzword that has been around for many years, and it's a buzzword like, you know, AI and defense, and it's all been around. And you know, people got excited about it probably like a couple of years ago, but now it's really a diluted word, and people don't understand what it actually means or can do in many times. But what's more strikingly is that 84% of the digital twin initiatives in the industry, in the heavy industries, actually never make it after a pilot project. So you have this really, really long pilot phases, and the opportunity cost is massive. We're losing about $1 trillion only because these pilots don't really get into a fully fledged digital twin solution. And why is that? How can we finally wake up? How can we change that? So the real reason that digital twins are stuck, and that's in general not only related to the physics AI digital twins we build, is a systematic challenge. And there's 3 components to this systematic challenge. One is the complexity of the assets itself, the brownfield complexity. And I think, has any one of you ever been on an offshore oil platform? I think there's only one person because he's going to speak about it, or 2 in the room. But actually, to get on an offshore oil platform, to visit it, you have to have a 2-week training, and you need to dive into containers, and you need to learn what to do when a chopper crashes. So it's quite a bit of a preparation to go on an offshore platform. And we have been applying our technology to the 2nd largest offshore oil platform in the world, from ADNOC. And this is where you can truly learn that your technology can be as good as it gets, and it can be outstanding, and it can be fast, and it can be scalable, and it can be in a library approach like we do it. But it's very hard to really overcome this brownfield complexity with technology. And 2 things you need to do it is you need to overcome the fragmented ecosystem, and there's no single vendor yet. When we go into factories today, we have so many different data sources, so many different vendors. So that's the 2nd part, and the 3rd part is really about siloed governance and about different decision strings. So how do we actually approach this? We really want to deploy a new operating model, and we need to solve not only the technology but also the adoption and the enablement. And it's very wonderful today to have all these pillars here. So we have the technology core, which is what Bosch Digital Twin Industries has built. And we will hear from Patrick, our CTO later, how we do it differently. And as a little sneak preview, we are having a library approach, and we have a combination of physics and AI that helps to actually deliver these projects very fast and get ROI within weeks rather than like 2 or 3 years. You need the industrial proof, and we will have Dr. Saladin here from the ADNOC Digital Factory, which is one of the most advanced digital factories in oil and gas that uses our technology in a consortium together with other players. And then you need the orchestrator. And I'm very happy to have MBK here as an enterprise enabler who orchestrates and who really takes the whole thing together, going up to on-demand production of replacing parts. So they really sort of complete the arc here. So we will see all these different views and get a really good understanding how we are able to solve these failures and misconceptions that have been there over the last 10 to 15 years. When we very much look at a simplified level on the evolution of digital twin technologies. We are really moving from a reactive technology where you are simply fixing something when it's broken over a preventive, predictive into a prescriptive technology. So simplified in a way, it's from just repairing something that's broken over understanding when it's breaking into autonomous behavior and recommendations for the factory. What are the sort of topics you're targeting, and where is really the value created within these concepts? And there are some ones which are quite obvious, and then there are other topics which are maybe not as obvious as you would think. The main driver, obviously, for applying these technologies is reducing downtime and operational expenditure. Now, with the conflict in the Middle East and a lot of disruptions and resilience programs, you're looking more into increasing production efficiency. And again, when you talk about a factory, 5% is a lot, or 0.5%. And with these new concepts that we use, we've seen some staggering results, where we go up to 40, 50% sometimes in efficiency. And through reverse engineering, through redesigning the concepts of how the oil and gas production or energy production is actually structured. So there's a lot of really interesting concepts. It's clearly the concept of predictive maintenance, and we will hear more from MBK about that. And it's about reducing average costs and improving operational efficiency. So if we look, at what has been achieved today and what really is like a theory, we can already see $1 trillion impact, and it's quite stunning, the ROI for some of these customers, because they've invested maybe $1 million or $2 million in this technology, and they've seen sometimes an ROI of up to $200-300 million. And we're talking about some really sophisticated customers. On the one hand, like ADNOC, which is the Abu Dhabi National Oil Company, which has a very sophisticated tech stack. But we're also talking about companies like Sonatrach, which is an Algerian company which contributes 26% to the GDP of Algeria, and which is at the very much beginning. And they were even able to use these simulation technologies because it doesn't require a lot of sensors and hardware on the ground to achieve results. And we'll talk about these just to highlight it with the case of ADNOC, which we will see in a second from Dr. Salah in a video. Unfortunately, he wasn't able to come here today because he couldn't get a visa. So you see, you have these technology people wanting to come to talk about technology. And unfortunately, they don't receive a visa, but that's another topic. We have a wonderful video from him. So in the case of Sonatrach, which is a very interesting case that shows really the power, there were actually the problem they had these heat exchangers. And in a very simple way, a heat exchanger is a pipe where something flows through. And these things were breaking down all the time. So they asked us to look at the data, and we were able to predict the remaining useful life of these heat exchangers, and by really understanding how the oil and the fluid flows through these heat exchangers. And the data was so precise, it was over 95%, that they were able to go back to their insurance and reduce the insurance costs by 25.5% on the critical infrastructure and critical assets. So one thing what Patrick will talk about is how we really approach it from a technology perspective. We are here at a technology conference, so I leave it to Patrick to explain this. In a very simple way, what we do is we take these simulations, we put them into reduced order models and then into algorithms that can be fed by different data points, and that allows us to be extremely fast. Like, when we started, we were about 1,000 times faster. Now, in some cases, we can go up to 1 million times faster in these predictions, which means you can act in real time, and it's super, super critical. So, what are the key sort of, game changers here? It's really getting out of these, dead pilot phases, really helping the industry to not only have the technology, but actually apply the technology in a meaningful way and to create value for them. And increasing the speed of implementation, going from 6 months, 12 months, 18 months problems that are not solved into like very short cycles of ROI, like getting results within days or weeks. So let me open the panel here and let's introduce my guests today. I'm going to start with Mansoor on the right side, who is here and who will talk about the enterprise enabling and about the complete ecosystem and how it's brought together with our technology. And Mansoor was 30 years in the energy industry. He was the chief commercial officer for Honeywell, and he was also the general manager for Microsoft in the Middle East. So he has a really deep domain expertise. And he started MBK Global together with a couple of other really intelligent people from the field, and they are together with us actually implementing some of these projects. Then we will have a video from Dr. Saladin, who is the chief visionary and architect of the Abu Dhabi National Oil Factory. They are probably the most advanced ones. They built their own tech stack. He was inspired by the NASA, so the control center actually is a replication of the NASA board control room, where they have all these softwares and data flows coming in. And the good thing is, with all bad things, that in the last couple of weeks with the conflict in the Middle East, we really learned how this technology can help them to make not only better decisions, but also to be more resilient and independent of the world in a way. And Mansoor will elaborate on that as well. And then I would like to hand over to Patrick now, who has built the platform over the last 4 years and who is the technical expert here and who can hopefully answer the more complicated and advanced questions. Thank you.
All right, thanks a lot. Yes, so I will try to connect those use cases that we already heard to the technology core, what is happening behind the scenes. And let me start with a basic problem that we're trying to solve, which is the case, I think, in many applications, also in our use cases in the energy industry as well as process industry or critical infrastructure, which is mapping data to insights. And it sounds simple. You may have AI already in mind. You may think of using agentic AI and so on, which is, I wrote future, but it's actually the reality. But if you think about it, it also has some drawbacks. I see this trend a lot in the industry, that we have a data layer. It can also be contextualized. It can be a semantic data layer. But just putting, let's say, AI or agentic AI on top can lead to good results, but it's often not explainable. When it comes to robustness, it's very hard. And if you have a use case where you have limited data only, if you think about a customer with a gas turbine, you don't want to ask the customer to run the gas turbine in a faulty stage. So you just have healthy data as an example. And in all those use cases, that's where physics is really still the benchmark. So it's not a either or. I'm not against AI, but it's really the combination that is, I would say, the secret sauce for us. And how we use this concretely is you see it in the middle with a digital twin. So we combine physics-based models with data-based models. We call this hybrid modeling. What this means from a technology angle is there are many ways to combine that, but in the end, it's always about turning data into meaningful insights and quantifiable business impact. And the data here can range from diagnostic data over process data, sensor data, but also historical data or test reports. Even user manuals can help. So all of this is combined, put into the digital twin. And the results are then those insights which can lead to a reduced downtime or more ideal parameterization of your running assets from a simple pump up to an overall process, for example, in the oil and gas industry or steel industry. And we can also do more advanced things such as what-if scenarios. So using the same example of the gas turbine, with those digital twins, you can now answer also questions, what happens if I change a parameter without doing that in real time? So yeah, that's more or less what we do. And now, let's say in order to avoid to do that for every use case from scratch with new data, or for every customer from scratch, what we have come up with is a template library. So we have identified the most critical assets, the most critical even components, so even like a ball bearing on the lowest level up to like whole processes. And we have, let's say, we have templates starting from which data do we need, what algorithms do we use, again using hybrid modeling, and up to the insights that we give to the customer. So here you see a, let's say, a small overview, a small insight of some of those machines and assets. And behind the scenes, all of this is backed by advanced algorithms. I already mentioned hybrid modeling. Something else is our virtual sensors, for example. So we have use cases where it's not possible to put a sensor exactly where you want it to be, and that's where simulations come in handy, and translating those simulations also into something that can work in real time. You don't want to wait for hours to get your insight. So that's something that we're working on, and a lot of more other techniques. So Albert already mentioned that number 10,000 times faster with simulations. So where does that come from? In the end, let's say we use high fidelity physics in real time, but we use surrogate models to break that down. For example, reduced order models, which are very specific to the use cases and to the insights that we provide to our customers, and that's why we can bring that number down from days to milliseconds or seconds. This is one of the parts, the simulation side, but of course this is always combined with AI to increase the robustness. And of course, this is whatever I spoke about until now is like the intelligence core. So this is where, let's say, the magic happens, where we actually produce the insights that our customers pay for. But of course, to run that end to end, you also need a lot of other building blocks. And our goal is to also make those building blocks configurable instead of customizing them for every customer. So I think an hour ago the CEO of N8N spoke. So you see something similar here as well. We're using this flow concept, but much more specific to our industries, and also using the templates, using the algorithms that we built specifically for our target industries. So, for example, if you want to calculate the mechanical efficiency of a pump, you just use the node for that, and you can connect it with your incoming data, and you can produce an insight that you can visualize in a configurable dashboard. But also, of course, the vision is, and it's partly already reality, to close the loop and to use those insights to autonomously drive operations in plants, for example. There are other important points. Maybe let me highlight this one point here, which is the creation of knowledge network and the innovation and collaboration. So we always work together with the people who are sitting in front of the machines. We're not pretending to know all the machines worldwide and know all the use cases, but we have the capabilities to transfer that knowledge into the digital world. And that's why we really sit together with the operators who are sitting in front of the machines since 30 years, and they just listen to it and hear if something is going wrong, and we use all those advanced technologies to transfer that knowledge into our algorithms. And finally, following the same, let's say, configuration set of customization approach, so we're quite customer-oriented when it comes to the deployment. We have customers who have already data in the cloud, but maybe struggle with getting the insights that they want. We have customers who start from scratch and just have, a pump that is failing continuously and they don't know why. So there we would provide the complete stack, usually as a SaaS model. And we also have advanced customers who have very critical assets that they don't want to connect to the cloud, or where you just have a huge amount of data where you just run into technical limits. And that's where on-premise deployments and hybrid cloud deployments come in handy. All right, so that was a quick overview of our technology core, and now let me hand it back to Albert.
So thank you, Patrick.
Sure.
Thank you very much. So I think the key takeaway is really going from configuration, from customization to configuration. And that really helps to solve the first big problem, which I introduced in the beginning, that we have these very large structures, really complicated brownfield operations, and historically a lot of approaches were just to go there and customize something, whereas we think the best approach is to have this library and stitch it together. And the example we're going to see now is actually very impressive, because we're talking about the second largest offshore platform. Our library has replicated over 700 critical assets on that offshore platform, and really helped ADNOC to solve not one, not two, but many, many problems. And the interesting thing is, if you look at it, you would say, Bosch, itself produces over 300 million components per day. So we know how to run a factory. However, we don't produce any of these heavy assets. And you could ask yourself, why is not the OEM producer actually supplying this sort of technology? Why is not the OEM producer doing all that? The thing is, they tried, and in the case of ADNOC, they tried for 3 years, and ADNOC even terminated the contract and said, we're so desperate, here's this insane requirement, which is, to have a solution that takes the accuracy from 60% to over 95%, we're today at 98%, and to have something that's much, much faster. And they wrote this requirement, and that's actually how a lot of this technology and ideation was born, based out of this real-world example. And we're going to see now Dr. Saladin, which I introduced before, who is the chief visionary of the ADNOC factory, and he's going to explain in his own words what they're doing and how it creates value for them and how it helps them. It's quite technical, so if there are any questions on that afterwards, I'm happy to help you to understand it. Do I need to press play, or you do it for me?
Hello, ladies and gentlemen. My name is Dr. Saladin Shahar, the Chief Architect and the Project Manager of ADNOC Offshore Digital Factory. The concept on the high-level architecture on the digital factory, which is driven by what we call the reality-based predictive analytics, diffusing the data digital twinning with multi-physics digital twinning. The input comes from ET, OT, IT, as well as the digital factory internals, comes to the internal models within the digital factory. One of them is the Bosch hybrid digital twinning advanced technology, as well as the concept considering rock to stock concept from the reservoir up to the loading arms, including all within assets like rotating, static turbomachinery, piping, structures, reservoir, subsurface, and subsea. Deliverables is impacting or giving the insights and prediction, advanced prediction and process optimization, predictive analytics of full spectrum of assets, on the maintenance, operation, HSE, integrity, structural, as well as the subsurface. Coming to one case or use case, which is we have completed or done among of other many cases within the digital factory in offshore, is our optimization of the ultra-filtration system within our water injection plant. So for this, the digital factory taken the lead to do model complete what we call sulfate reduction plant. Okay, we have some chronic issues on the ultra-filtration vessels, which has impacted our production from this water injection plant, because water injection it means for us almost is the oil production. And a chronic issue on this ultra-filtration system or vessels is a premature failure of the bolts or the ultra-filtration candles or membranes holding plate cracks, as well as the less water filtration purity required for such tight formation of the reservoir. The finite element, first of all, the vessel has been modeled using the multi-physics concept, using the Bosch digital twin model. We have done the CFD, computational fluid dynamic analysis, using the standard Navier-Stokes equations, but with the patented Bosch concept of reduced order modeling, which has accelerated and minimized the solution time of the CFD. So we have the velocity profile, the pressure profile, as well as the temperature profile, and eventually entered to the next stage of the Bosch digital twinning, which is the finite element analysis. So we have got the complete von Mises stresses distribution and profile, and eventually part of the modeling done is the Tresca modeling, which is introduced by us to the Bosch, and they have clubbed in their model. So accordingly, we have the full fatigue flux. Accordingly, we have calculated how many cycles we can operate with any anomaly detected by the model. We have succeeded to increase the oil production by 18,000 barrels per day. And as per the simulation, we have increased the filtration capacity by 35%, increased oil production by 12.5%. And a good example how the integrated hybrid digital twinning using the multi-physics concepts with the reduced operating modeling or the reduced order modeling accelerated the solution using the Bosch concept of RO. The life extension of the previously modeled or faced bolts fracture fatigue, as well as the holding blade, we have increased the lifetime or the mean time between failure by 5 times of this filtering. I'd like to thank Bosch for the given opportunity to us to express our experience with Bosch hybrid digital twinning, and also their flexibility on accepting our technical input adapted in their model. And this is give us the leverage to show what is the potential of multi-physics in our simulation as well as in digital factory. This is only one case. We have more than 240 models created.
So I'm sure it would have been a bit more inspiring if someone is in the room, and but we're still glad. So let me hand over to Mansoor and to MBK now. The green button. Yeah.
Good morning. Great to be here, and pleasure to be part of this event. As mentioned by Albert, I do have quite a history in the oil and gas industry, energy industry, having lived almost 30 years in the Middle East now. And what is happening today in the region has been anticipated, meaning that technology was thought of to ensure that we drive resiliency in the way we operate assets. MBK Global is based in Qatar. It has been formed over the last couple of years, but truly embedding very differentiated technologies in order to integrate those technologies and answer customers' needs. One of our great partners is Bosch Digital. And we do have other partners which are integrating this, the building block that we have established. Sumud is the Arabic word of resiliency. What we mean by that is truly how we drive resiliency across an enterprise, regardless whether it is oil and gas, manufacturing, any enterprise. Do you know what is the cost of shutting down one platform for 1 day? Give me a number. $1 million. Multiplied by 14 for 200,000 barrels a day. If you talk about 10 million ton per annum petrochemical plant, it's about $15 million a day. And those shutdowns can happen because we don't truly see things coming. What is amazing is truly that collecting the data, and we have a huge pool of data today, we are in a position to understand how the process is evolving and how things are coming, but we don't listen. We don't see what's coming. We don't have the technologies to analyze the data and turn it into insights and predictions. That's the C component that we're seeing here, and I'll be a little bit more deeper on the coming slides. But then once we have identified the trend, once we anticipate any possible shutdown or malfunction of an equipment which will cause a shutdown possibly, how to address it. So it's not about just seeing it, it's about acting in a very prompt and rapid fashion. We cannot afford 1 day loss of production. That's a huge loss of revenue for any organization. Hence, we need to look at all possible spare parts, all possible equipments which could address that specific deficiency on the equipment that we're looking at. And that's the find. The find is truly an end-to-end supply chain to look at all what is available within a country or multi-countries. And then what is also important is to look at if the equipment or the spare parts is not available. How to ensure that we have it available within a week. And typically, if it's not available, we're talking about 11, 12, even more weeks because of the manufacturing of the equipment, because of the lead time, because of transportation, because of the time it takes to get many things rolling when it comes to procurement. So it's a huge loss of time. So that's where the make comes into picture. So I'll be a little bit more specific around those 3 pillars, which are building the resiliency within any asset, not only oil and gas. Of course, this is very much adaptable to the oil and gas because our biggest market as of today is Qatar. And we know that Qatar is the largest producer of LNG globally. They are today producing 70 million tons per annum. They are doubling the capacity within the next 2 years. And that comes with all sorts of challenges when it comes to operation. So C is about developing physics models, digital twins, understanding exactly the behavior of each and every equipment, and be able to predict the behavior, being able to forecast this behavior over time. And that is important because by understanding the true dynamics and physics of an equipment, you can infer different state of the equipment. And ahead of time, you can take actions to mitigate any potential deficiency on that equipment. It's also helping in terms of ahead of time detecting anomalies and reacting to it. Again, it's about listening what the plant is telling us. We don't listen often, unfortunately, because we don't have the culture, we don't have the tools, and that's exactly what this type of technology, digital twins, is providing. And this is the partnership we have with Bosch Digital Twins, which is amazing. I mean, you have seen the the video from ADNOC. ADNOC is one of the largest producers of oil and gas in the region, in Middle East. It is one of the most advanced, if not the most advanced national oil company globally when it comes to digital adoption. And I may be, basically taking some risk here, but probably ahead of some of the Western manufacturers, or say oil and gas companies. But they have invested tremendously. And the objective of this of ADNOC is truly to operate autonomously. Autonomous is a key word within this organization, any organization oil and gas today, because they realize that the scarcity of resources, the scarcity of competencies is diminishing, the competency. So basically, they're looking at turning those assets into autonomous operation by infusing the know-how within those assets. And that's exactly what digital twins brings into the table. But then you need to close the loop in terms of autonomous operation and autonomous optimization. And that's a partnership we have with Optvance.ai. That's a startup which is providing AI-infused applications to optimize multiple layers between the digital twin and the automation systems. And then you can close the loop and operate autonomously those assets. So the outcome of ADNOC is amazing, and definitely looking forward for more similar outcomes in the region and beyond. So that's what C provides as value. Then once we have identified a malfunction on a specific equipment, how to address it, how to ensure that we act on it now, and avoid to have, I would say, going through a search of equipments across multiple OEMs. And by the way, one key issue today is 60% of the oil and gas companies, plants, assets have been built between 1960 and 1990, 60%, which means that all those equipments at site are obsolete. They are not reproduced again. Hence, and some of the OEMs have been merged with others, some of them have disappeared from the market. So hence you have an equipment and you have limited spare parts, and how to address this issue. So that's what Find does. It looks at the end-to-end supply chain across a large ecosystem of suppliers, connecting the dots between supply and demand, understanding if an equipment is available somewhere, and if not, what to do about it. But at least it gives you, in no time, the full picture about end-to-end supply chain and where to look at to get this equipment identified and shipped to your asset. Now, if the equipment is not available, of course, you need to do something about it. And that's the other component of resiliency, making your own equipment using adaptive manufacturing. So meaning you do 3D printing on the equipment, and instead of waiting 12, 18, 24 weeks to get your equipment site, and that's translates into that time of reduced capacity production or that time of shutdown, which is hugely costly, you do it within a week. And basically what it does here is really also getting the digital twins models, which have been already developed, hence here Bosch, into the manufacturing of the 3D equipment. And that's, I would say, a massive gain in terms of reducing the time it takes to repair any issue, as well as ensuring that you build constantly on resiliency and production. So that's about basically so that's, I would say, the overall concept that has been established, that has been, which is basically in place. And the integration of these three pillars truly makes a big difference, because these three pillars are set to close the loop between operating and then manufacturing spare parts, and then using it again to keep production continuous. With that, thank you very much.
You can stay here for the questions. Thank you. So thank you very much, Mansour. I think it's pretty impressive, and it shows that the digital ultimately turns back into something tangible, something physical, something you can touch, which is a spare part. And there's a lot of improvement that can drive sustainability, that can drive obviously profitability, but many different topics. And I think there's a lot to explore over the next years, and we're very happy to do this jointly together with you. So there is room for some questions. Are there any questions? Yes, what's your name, please?
Simon.
Simon, hi Simon.
My question would be, how do you see working with big companies like Bosch in comparison? Last week I was in London working with a startup that is doing all of this like digitalization from auditing from exactly those chemical plants and like other plants as well. So how do you see working with very big companies in comparison to maybe working with startups or other companies? Where do you see benefits, pros and cons maybe? Because there are a lot of startups here in the room as well.
Yeah. Very, very good question. I can answer. As mentioned, we have established a platform which is building blocks. We do have deep domain expertise. I mean, myself, 30 years in the oil and gas industry, and my colleagues as well, the founders of the company, which means that we understand exactly what is building robust, resilient operating company in terms of process production. And so what we did is truly looking at the different areas and trying to ensure that each area is filled with world-class technology, world-class company, and really bringing a very robust platform. Customers with whom we deal with, ADNOC, Qatar Energy, LNG, Qatar Energy, Saudi Aramco, and then beyond, of course, Sonatrach in the case of Bosch, are very, very exigent when it comes to robustness of technology, proven technologies, and ensuring that it is one single platform. And that's exactly what we do. We integrate that paradigm. And so, to your question, how do we see, I would say, working with large organizations? In today's world, it's a perfect synergy. And the value we bring is equally high compared to the huge value Bosch brings. So together we bring, I would say, 1 + 1 = 5 to 6 with the customer. So I think the barrier of entry has diminished tremendously compared to what we have seen in the past, because of, I would say, the technology, because of the differentiation we bring. And I insist on this point, the domain expertise. When you talk to people who have domain expertise, that makes a whole difference compared to people who just talk IT. I mean, I work for Microsoft myself, so I'm also an IT guy. But I believe that basically the deep domain expertise makes a huge difference, and that's what we bring as well into the mix.
And to give you a very pragmatic answer to that is, Mansour brought one of his leadership team members here, and he was walking around yesterday talking to some of really exciting startups here, and was like, okay, this is how we can integrate it as well. So I think in a long story, what you say is you need, in a short, not a long, you need the domain expertise in order to understand the problems and talk the language. But MBK in special, has built a platform where they look at other technologies that can fit into this broader picture and that can help. And if you go back to the very first slide that I was showing, I think one of the challenges is the complexity in the brownfield, and one of the answers is to have someone who can orchestrate it, because there is not a single company that can do everything, because the requirements are so insanely vast and so specific. And the challenge is more like to build technologies that can adapt to these environments quick enough. And sometimes the technology is fast, but the implementation of the technology is slow, which means the project is killed because there's not enough patience for it. So yeah, I hope that helps. Another question? Hi.
Good day. Yeah, thank you very much, Miles Margo. Maybe a question to all, really, or whoever can answer. When you set out to do the digital twin, and in this case, they had a production capacity increase of 18,000 barrels a day. Did it start with an ambitious goal, like can we achieve 10 to 20,000, or was it let's build a digital twin and see where we get to? So really about how did you what was the goal from the beginning, and how did that come out, or how did that play out?
South African accent I hear.
I think in this case, they started with a very specific problem, and the problem was more like on failures, and they had this unpredictable failures. And when they started to look at the data, and this is what I've said before, they gave the data to the pump manufacturer, and they said to them, "Can you help us fix the problem? Why are these pump systems breaking down?" And they couldn't find an answer. And then, we run our simulation data. We gave them the answer on how this can be improved. And we said, by the way, there's a design change. If you change the design of the spare part, something will happen. Something which, in our data results shows you can increase the output by, up to 30,000 liters. And then it comes in to have someone who is capable of 3D printing titanium grade 5 or whatever it is. So it's like, back in the days you would have said, it's almost like tuning in the automotive industry. You have your Porsche and you start to change things. But you think, would a big enterprise that has critical infrastructure, which is state-owned, do that? Yes, they do it. They changed it. They understood it. And by the way, this is just one single offshore platform. And now that the concept is there, they really can, start to take this onto multiple platforms. And if you have read the news that the UAE stepped out of the OPEC, it's a big signal, because basically they will produce, double their production in the next year. So yes, they sort of maybe discovered it by coincidence, which can be good, but now they know what they have, and that's good for us.
And it all starts with the proof of value, as mentioned by Albert. Proof of value is the step 0, understanding exactly based on the data available, proving the value, and based on that, they initiate the project. And that's typically how NOCs, national oil companies, operate in the region and beyond, as well as international oil companies.
And maybe just to close this off and back to your question as well, by the way, this is built in a consortium. There's about 8 different companies that work together on that. We can claim, that we do the intelligence layer, and that's, the most valuable part when we talk about value. But in this ecosystem, there is, very different sort of topics that can be addressed by different companies. And that's also, when we go out, people say like, are you doing digital twin? Siemens is doing a digital twin. This startup is doing a digital twin. Physics AI is doing a digital twin. And they're all doing something, but they may have very different approaches or are just supporting a different part of the value chain. Yeah. Any other questions in the room? No? Yes? I think we're good.
Thank you.
Wow.